Hey everyone, Chang here and welcome to my channel. Today we're going to take over a tool that's normally used in English or in science and actually use it in math. Today I'm going to talk about Venn diagram. Now Venn diagram, usually when you use it, you're comparing two kind of different things, mainly different, right? That's why you have a certain area that belongs in one Venn diagram, something that belongs in another, and in the middle, usually a little smaller, is where they share common traits. Now, what we come to realize is that there are certain type of problem in math where Venn diagram is extremely useful. Now, these are specific problems. They're counting problems, and they're specific type of counting problem. But when you encounter them, whether in a test, in a competition, or in, I guess, your standard everyday class, right? It's actually extremely useful because it helps you stay organized and helps you visualize the problem. Let's look at this one right here. In a room, you have an unknown number of people. 19 have a dog. 15 of them have a cat. 8 of them have both, and 6 have none. How many people are in the room? Now, that's a lot of information. And just trying to understand it or organize it in a way without a visual representation can be difficult. Some of us can do it. Some of us maybe have trouble. So what I come to realize is that with Venn diagram, these problem actually becomes a lot easier. So let's look at this. We're talking about dogs and cats. So let's just have two little circle things, and my drawings are terrible, right? Two circle things with the D for dog, C for cat, and inside the sliver is usually, what they share. And then outside sometimes you will see there's occasion where they would do something like this, where this rectangle represents the entire population and then you start separating them. So in a room you have an unknown number of people. You have 19 who have dogs, 15 that have cat, 8 have both, and 6 have none. Well, in this case, let's just do both first. So 8 individuals have both a cat and a dog, right? So in this case, well, if we have 8 and we know that 19 of them have a dog, there's an overlap because guess what? The 8 who have both is going to be counted in the 19. So instead of 19 here, technically what we have is 19 minus whatever they shared. So that's going to be 19 minus 8 right here, which is technically just 11. Okay, that's dog. Well, we can do the same reasoning for cat. If there's 15 individuals that have a cat, and we know that overlapping, we have 8 who have both, then we technically here is not 15, it's actually 15 minus 8. So in that case, that's 7. Okay, we also know that we have 6, let's just say out here, that have none of them. They don't belong in either or. So in that case, just like this alone, we can immediately answer the question because it's saying how many people are in the room total. Well, we know that there's 11, right, who own only dog. We know 8 owns both, 7 own only cat, and 6 own none. So 11 plus 8 plus 7 plus 6. And just like that, we can figure it out. What is that? 19 plus 13. So that's technically 32. So there's 32 individuals in the room. And notice that just using this Venn diagram, even though not normally seen in math, right, we can organize this problem and immediately we can reason out the numbers and figure out the answer for this question. Now, this next problem is sort of stretching the boundaries of what we can really do with Venn diagrams. Now, my understanding of Venn diagram, at least when I use it, this is usually the limit. There's 3 of them. 3 topics that we're focusing on. Now, of course, there's more in which you can do some like creative Venn diagram that includes 4 or more. But at that point, just because maybe it's just me, I'm not organized enough to keep track. I actually start getting more confused when there's a bunch more. But at least with 3, we can handle that. So this is a pretty long problem, but I think we can do this. In a class, students were asked to choose at least one favorite subject. So they have to pick at least one. 30 chose math, 28 chose science, and 26 chose English. If 13 chose math and English, 15 chose science and English, 11 chose math and science, and 4 of them chose all 3, how many students are in the class? So this Venn diagram, there's 3 subjects with them potentially sharing, because they had to choose at least one. That doesn't mean that they chose only one, right? And we're trying to figure out with this, with all the potential overlaps, how many students are in the class. Well, first and foremost, we draw a Venn diagram like this, and then we separate it by its subject. We have math. Let's just do M right here. We have science, and then we have English. Now, hopefully you guys start to realize this, but if not, I would always say, at least just a strategy that works for me, is just to go for the one that is all overlapping. That means the one, in this case, of all three. Well, and then from there, we start breaking it down and then reason our way through the rest of the Venn diagram. So the first one is 4 of them chose all three. So 4 we don't have to worry about. We're just going to put 4 right here. Let's just do it right here. It's going to be a little small 4 right here. All right, cool. Now we can start working through some of these. Well, this one right here, what they share is going to be M and S. That's math and science. So we have to look for the one that's talking about math and science. Right here, math and science. 11 chose math and science. Remember, 4 of them chose all three. So out of the 11, 4 already chose all three. So technically it's not 11 in there. We're going to have 11. Let me see, 11. If I could fit this in here. Minus 4. And that's just going to be 7. 7 right here. All right, cool. Well, if that's the case, we can use that same reasoning and go through, well, this one's math and English, and math and English is right where? Math and English right here, 13. 13 chose it. Remember, 4 is already overlapping, so it's going to be 13 minus 4, which is just 9. And I'm probably going to go out of the bound so you guys can see it. Okay, and then this one right here is going to be our English and science. English and science is right here. Science and English. 15 chose it. So out of the 4, we're going to have 15 minus 4, which is technically 11. So notice this. The all overlap, then all of a sudden I spread out to the ones that are sharing 2 overlap. And then now we have the remainder. Well, in this case, if we have 30 chose math, and we're looking at this right here, and we have all of this right here that were overlapped, so we just want the rest of these are just people who only chose math as their favorite subject. Well, in this case, we have technically 30, right, which is the total, minus, we have 7 who chose math and science, we have 4 who chose all 3, and then we have 9 who chose math and English. So we have to subtract that as well. Let's just put it right here. So it's going to be 30 minus 7 minus 11, because minus 4, right? So minus 9, which is minus 20 total. So in this case, there's only going to be 10. Hopefully I did that math correct. 30 minus 7 minus 4 minus 9. Okay, cool. All right, now the next one right here, we're looking at only science. Only science, there's 28 of them. Well, we have to get rid of all the overlap. So technically it's going to be 28 minus 7, which is the overlap of math and science, minus 4, which is the overlap of all 3, minus 11, which is the overlap of science and English. So 28 minus 7, that's what? 21 minus 4, that's 17, minus 11, that is, well, 6. So in this case, 6 right here. And lastly, we have English, and the people who chose English is where? Right there, 26, right? So we're going to have 26 minus the overlap of 9, which is math and English, minus the overlap of 4, which is all 3, minus the overlap of 11, which is science and English. So 26 minus 9 minus 4, and minus 9 minus 4 is 13, minus 11, which is what? 24, so technically there's what? 2? 2 right here. All right, now, going through all this is so easy for us to lose track of the actual question itself because we just spent a good deal trying to fill in this Venn diagram. So let's look at the question again. How many students are in the class? Well, we have all of these guys right here. And this is assuming that there's no students that can choose none because, well, the problem itself says it. So what do we have? We have 10 plus 7 plus 4 plus 6 plus 9 plus 11 plus 2 is the total number of students in this class. Now let's see if we can do this really quickly. So 10 plus what's that? 11, that's 21, plus 9 is 30, that's 36, this one 47, 49. Hopefully I did this correctly, or it's gonna be embarrassing. All right, cool. So total number of students in this class after all the overlap, after breaking it all down and reasoning it through each and every one of those sections of Venn diagram, we know that the total of students in that class is 49. Alright, so for our next problem, this is a counting problem. Now, the problem with counting is that we have a tendency to sometimes overcount or undercount. Undercount when we accidentally exclude something. Overcount when we actually count overlapping things as two different things. Now, I'm going to leave a link in the description down below where I go into extensive detail in hopings of finding ways to prevent that kind of error from occurring. This one, luckily for us, the problem is structured in a way where undercounting is not really possible, but there is a possibility for overcounting. Let's look at it. How many natural numbers less than or equal to 100 are divisible by 5, 6, and or 7? Now, the common error for undercounting is usually excluding 0. Luckily for us, natural numbers automatically exclude 0. So, we don't have to worry about that. Overcounting, there are numbers that could potentially overlap, like ones that are divisible by both 5 and 6 or 7, right? So let's just start breaking it down individually, then we're going to use the Venn diagram. The first one is 5. Now, in order to find all the numbers that are divisible by 5, we just look at the multiples all the way until it hits 100 because it's less than or equal to 100. Well, 5 times 1 is 5, 5 times 2 is 10, so on and so forth, all the way until 5 times 20, which gives us 100. So technically, there's only 20 numbers that are divisible by 5. Well, the next one we're looking at is 6. Now, in order to find that, we actually have to find the number that's closest to 100, the biggest number, that's still divisible by 6. 99 probably don't work. 98 won't work. 97 won't work. 96, let's try 96. So, we have 96 and we divide it by 6. Goes here once, 6, subtract 36, and then that's 16. Okay, so that means there are 16 numbers that are divisible by 6, and then the next thing we have is 7. Well, in this case, 7, 99 probably won't, 98, I think it might work. Let's try 98. 98 with 7. Goes here once, 7 subtract 28, that's 14. Okay, cool. So there we go. So we just found each and every one of them individually, right? 20 numbers divisible by 5, 16 numbers divisible by 6, and 14 numbers divisible by 7. Now, once again, possibility of overcounting because there are certain numbers that are divisible by both. For example, let's just look at 30. 30 means that whatever is divisible by 30 is actually divisible by both 5 and 6 because 5 and 6 multiplied together gives you 30. So in this case, you have 30, 60, 90, that's it. So there's 3. Okay, well, let's look at another combination. Let's look at 5 and 7. 35. Multiples of 35. 35, 70. Okay, and then after that, it's bigger than 100. We don't care. Okay, cool. Now, the other one, we have 6 and 7. That's 42. Well, that's 42, and we have 84, and that's it. Everything else, we don't care. All right, cool. There we is. Is there one where it's a multiple of all 3? Probably not, right? Because 5 times 6 is 30, times 7 is what? 210. That's way bigger than 100, so we don't care about that. All right, cool. Now, we have all this. We have all of these and all the potential overlap. Let's just put them in a Venn diagram and see what happens. We have our 3 type of Venn diagram because there's 3 numbers that we're worried about. We have 5, we have 6, and we have 7. Okay, well, let's see. Nothing, even though it's drawn like this, I just draw like this because out of habit. In this case, technically, there shouldn't be anything touching here because there's nothing that's divisible by all 3. Well, in this case, what else? We have 2. They're divisible by 2. So 5 and 6, there's 3 of them. Let's just put 3 right here. And then this is 5 and 7, which is 2 of them. And then we have a 6 and 7, which is 2 of them right here. All right, cool. So those are all the overlap. And then we can start looking at this. Let's look at 5, right? There's 20 of them total, but then there's these 3 and 2 overlap. So technically there's 15. So let's do 20 minus 3 minus 2, which gives us 15. Okay, cool. Now, 6, what do we have? 16, and then there's the 3 and 2 overlap here for the 30 and the 42. So in that case, we have 16 minus 3 minus 2, which is going to give us 11. And then lastly, we have down here, which is 14 minus the 2 for each side overlap, right? So it's going to be 14 minus 2, which is going to give us 10. So how many numbers total, right, natural numbers, are divisible by both, or not both, but by 5, 6, and or 7? Well, in this case, we look at all the numbers in black, right? We have 15 plus 2 plus 3 plus 2 plus 11 plus 10. Well, let's see. Okay, that's 15 plus this one's 5, that's 20, that's 22, that's what, 33, that's 43. So 43 numbers are going to be divisible by all 3. So hopefully with that we can see that, I guess you could say, all's fair is love and war and math, right? Even though Venn diagram itself wasn't originally designed to be used in math, it doesn't matter. It's a tool that helps us stay organized. And if we can use it in math to make sure that we can solve the problem correctly, why not? Even though it's very oddly specific for certain type of problem, guess what? It's a very valuable tool. If you encounter these problems, I highly recommend just using Venn diagram to stay organized so we understand the problem and we can reason it out and figure out the total answer. All right, thank you again for watching this video. See you in the next one.